Hello students, in this video I will be talking about the topic of trees. This is the first part of the video, okay? And here I will be introducing you the topic of trees, some terminologies used, the representation of trees, okay? So what is tree? Before going to the introduction or the definition of tree, let me talk about the data structure. In the first module, we have learned about various types of data structure, right? So in that, we had something called as linear data structure and non-linear data structure. So if you remember, linear data structure means the elements or the contents are placed one after the other sequentially. So for example, array. In array, the contents are placed one after the other. Whereas non-linear data structure means the contents are placed randomly. So tree is one such data structure. Here, the contents are not placed one after the other. It is placed randomly, as you can see here. Okay. Now, let us come to the definition of tree. A tree is a finite set of one or more nodes. See here, these elements are called as nodes. And these lines that are connecting the nodes, these are called as edges. Okay. So the circles are called as nodes and the lines are called as edges. And look at this. Okay. Here, for example, if I take this node D, okay, again, some edges are there. Okay. And the edges again, you have some nodes. So you can consider this itself as one tree. Are you getting? This itself as one tree. And one more you can see here. See, this is a node. There is an edge and there is one more node. So you can consider this as one tree. Okay. So this would be the main tree. This would be the main tree. And these are subtrees. These are subtrees. For example, over here. So this is one and it has two other nodes. So this can be considered as one subtree. Okay. So you have to remember all of this. Also, see here. Now let us look at the definition. A tree is a finite set of one or more nodes. So it can have at least one node and more than one nodes. Okay. And there is a specially designated node called the root. That means your main node is called as the root node. This is your root node. And the remaining nodes are partitioned into n greater than or equal to 0 disjoint sets. See, here the remaining nodes, that means B, C, D, all this, they are divided into, they become other parts, right? So again, if you remember, I told you that there is a main root and some other nodes when they have their own nodes after them. So that also can be considered as another set of tree, right? So we have disjoint sets, that is other three subtrees, where they sit, where these sets is a tree, and these T1 up to Tn are called the subsets, sub trees of the root. These are the subtrees. So C and G is one subtree. D, H, I, and J with M is one subtree, or just H with M is one subtree. Likewise, B with E, F, K, and L is one subtree. The other one is E with just K and L is one more subtree. Okay, so if I have to define a tree, I would say that a tree is a finite set of one or more nodes such that there is a specially designated node called as the root, and the remaining nodes are divided into disjoint sets T1 up to Tn, and this T1 up to Tn are called the subtrees of the root. Okay, so that is how you define the tree. Likewise, we have some terminologies that you have to remember that is associated with the tree. So first one is node. What is the node? It says node. Okay, node. These are the items of information. So these are the nodes. J, I, H, D. These are the nodes. Okay. And what is the next one? The next one is degree. See here in this node itself, in this tree itself, let me show you what is the degree. Okay. See here. For example, I'll consider the node D. Sorry, B. Okay. So the number of child nodes that it has, the number of child nodes. So here B is having two child nodes, right? These are child nodes. This is the no root and its child. Okay, see. So E and F, two are there, right? So you can say that the degree of this particular tree with the root B is 2. Likewise, what is the degree of D node? The degree of D node is 1, 2, and 3. So the number of child nodes that it has. So D is having 3 child nodes. So that is why the degree of it is 0. 3. Likewise, what is the degree of C? Can you identify the degree of C? The degree of C is the total number of child nodes that it has. C is having only one child node. So that is why its degree is 1. Okay. And that is the degree of that particular node. What is the degree of the tree? The maximum of the degree of the nodes in the tree. For example, see here. This one, okay. So let us take D. D's degree is 3, correct? And what is the degree of B? B's degree is 3. B's degree is 2. Likewise, let's say A. What is the degree of A? A is also 3. So degree of the tree means the maximum degree that you have. So that will become the degree of the tree. So in this case, 3 is the maximum degree that a node is having. So that is why it is 3. Okay, that would become the node of the, that is degree of the tree. And see, sorry. And next one is leaf node, terminal nodes or leaf nodes. See, these nodes which are at the end and they do not have any child nodes, right? These are the nodes which do not have any child nodes. See, M is not having any child nodes. That means it does not have any node after it. So these nodes, which is at the end, and they have a degree of 0. They do not have any child nodes, so their degree is 0, right? So such nodes are called as leaf nodes. See the definition? These are the nodes that have degree 0 or node with no successor. They don't have any successor, right? So that is why these are called as leaf nodes or called as terminal nodes. Okay, so you have to remember leaf node means the nodes which do not have any child nodes or their successor is not present. What do you mean by non-terminal nodes? See, terminal means no child nodes. Okay, so if they are not leaf nodes, if they are not terminal, then obviously it is going to be non-terminal. For example, the nodes with at least one child. So I can say that C is non-terminal. All the internal nodes, see, A, B, C, D, okay, E, H. These are non-terminal nodes. The ones which are not having any degree, they are called as leaf nodes. If they have some degree, then it is called as non-terminal nodes. Okay. So you have to understand these terminologies because throughout the module, we will be using these terms. So before I go, let me recall these 5 things. There are some more, but let me recall these 5. So the first one is node. Node means the elements, okay, or the piece of information, okay, These are called as nodes. What is meant by degree? So, degree of a node is the number of child nodes that it has. Okay. Degree of a tree means, see, degree of a tree. For some nodes, we have mentioned the degree, isn't it? So, the highest number of degree that a node is having, that will become the degree of the tree. Okay. And what is meant by terminal node or leaf node? The node which does not have any child node to it are the ones usually at the end. These are called as terminal nodes or leaf nodes. And the nodes which has at least one successor or one child node, these are called as non-terminal nodes. Likewise, parent and children, parent node and child node. See here, for this particular, let me consider this one. See, D becomes the parent of D becomes the parent of H, I, and J. So these are the parent, this is the parent node, and these three, H, I, and J, these are the child nodes of it. Okay. So for a given node, if there is a successor, those successor becomes the child node. And for the child nodes, if there is a node above it, so then it becomes the parent node. So for example, this particular tree, if I consider, so C becomes the parent and G is its child. Okay. Likewise, let me consider this one. So B becomes the parent, its child is E and F. Likewise, if I consider this, E is the parent, K and L are the childs. Siblings. Siblings means if the nodes are sharing the same parent, like how you have your siblings, just like that. Okay. So, for example, here, if I consider this one, this E node, see, E has having child K and L. So, K and L are sharing the same parent, right? They have the same parent, E. That is why K and L are the sibling nodes. Sibling nodes. Okay. Likewise, what about D? Okay, in the if the D is considered as parent, since H, I, and J are its child, so H, I, and J can be called as siblings. Okay, an edge. What is an edge? I told you these lines. These lines are called as edges. The lines, okay, that is connecting the two different nodes. These are called as edges. Okay, path. Okay, so for example, if I want to find the path between, wait, if I want to find the path between, if I want to find the path between D to M, D to M, then the path is this, right? Likewise, path from A to K, let's say A to K. So it is this, from here, this, then this, A to K. So how do you define path? A sequence of consecutive edges from the node N to a node M. Okay, so the edges between two different nodes, those are called as the path. Ancestor and the ancestor of a node. See here. See, for example, ancestor. See, for your, we usually say, right, we our ancestors like that. So here, ancestors means for a given node, all its previous nodes. See here, for example, L. So for L, I have E, then B, then A towards its root, right? So we can say that the ancestors of L are E, B, and A. Are you understanding? Likewise, what is the ancestor of J node? Can you tell me what is the ancestor of J? The nodes from itself to the root. In that path, whichever node comes in between till the root, they are called as the ancestor. So here J, so this is one edge and this is one. So in between I have A and D. So the ancestors of J are D and A. Can you tell me the ancestor of M node? The ancestor of M node, this node, the ancestor of M is H, D, and A. Like this. Okay. And the level. So there is something called as level. See, whenever we have the root, that level is called as level 1. Then this would be the level 2. This would be the level 2. This would become level 3. And this would become level 4. So level means the number of if I have to explain it in very simple terms, like how many different steps are there. So for the root level 1, its child, then it becomes 2. Then if it is having some more child, that becomes 3 and so on. Okay. So it is defined by letting the root to be the level 0, or you can say it as level 1 also. Then you count from there. Okay. Then the height. Height means the maximum level of the node in the tree. Let me take some examples and you show you. See here. This is the given tree. Now, A is a root node. Are you able to understand? A is a root node. Yes, main node. B is a parent of E and F. B is a parent of E and F. Yes. C and D are the siblings of B. C and D. C and D are the siblings of B because they are sharing the same parent A. Okay, external nodes or leaf nodes. So K, L, E, G, M, I, and J. These are the external nodes or the leaf nodes. So either other than that, everything is internal nodes or non-terminal nodes. What is the level of E? What is the level of E? So for root, it is 1. Then this is 2. So level of E is 3. So what about the height? So height is basically, okay, basically what happens is the from here, okay, from here you count. So this is 1. So 2, 3, and 4. So that is your height. Then the degree. Degree. Degree means for a given node, the number of child nodes. So the degree of B is 2, it says. The degree of B is 2. That is E and F. The degree of the tree is 3 because the highest number of child is 3. So that is why it becomes the degree of the tree. The ancestors of M, the ancestors of M, so the ancestors are of M is H, D, and A. H, D, and A. And the descendants means like if there is a node, its child and its grandchild, like that. So for example, if I consider B, then its descendants are E, F, K, and L. These are its descendants. So for D, it is H, I, J, and M. It is very important you understand these terminologies. Okay. So you can take one example and you can try to find out the different terminologies for a given tree. Okay. Next is the representation of the tree. So trees can be represented using three ways. One is your list representation. The other one is left child, right sibling representation. The other one is representation as a degree 2 tree. Okay. This is very important and it has been asked in the exam many number of times. How do we represent a tree? So we will look at each of the represent. Sorry. We look at each of the representation. So list representation first, then left child, right sibling, and then degree 2. I'll draw one tree and I'll show you the representation. Okay. So first, let me take one tree. I'll take a simple tree just so that you can understand it. Then we'll take a complex tree and then E and F. I'll consider this one. Okay. Now let me start with the list representation. See, list. Okay. So I will be using linked list for this. And it is not any other type of list. It's just a singly linked list. So you see here, before I do the linked list representation, let me show you how this actually looks like. See, the very first node is A. So I've written A. Open the bracket. Start with the first child of A. First child of A is B. Correct? Now, okay, now what you do is check if B is having any child nodes. Check if any child nodes are present for B. Yes. So what I will do is I will write the first child node. So first child node is D. Okay. Before I proceed, check if D is having any child nodes. Check if D is having any child nodes. D is not having any child nodes. So what you do is you come towards its sibling. You come towards its sibling. Its sibling is E. Now you have to check if D is having any child nodes. E is having any child node. E is also not having any child nodes. So this part is done. So basically what you're doing is you're traversing legacy from A, then B, then D, then again going back like this. Okay. Then come to this part. Okay. B is done. Now what is left? C. Now check if C is having any child node. Yes, C is having any child node. So F. But is F having any child? No. But is F having any sibling? No. So we stop here. So we have come to this part. Okay. So we have considered all the child nodes and now you have to go back. So what you have to do is now you balance out the brackets. So 1, 2, 3, 1, 2, 3, and for the main you give 1 like this. Are you understanding? This is how you do the list representation. Now, how do you represent this as a linked list? Let us start with the linked list. See here. So first I will write the very first node. Very first node is having the value A, right? So I'll write A. Then I will check if A is having any child nodes. Yes, A is having two child nodes, correct? One is B and the other one is C. So I will write two nodes, B and one for C, like this. Now, what you have to do is look very carefully. This part is already done. I think I'll erase it off so that it's not confusing. Okay, this is how the tree looks like. Now, what you have to do is, see, A is done. Now check B. Is B having any child nodes? Is B having any child nodes? Yes. If it is having child nodes, you shouldn't write B over here. If it is having child nodes, so B is having child nodes. So I will not write it. What I will do instead is I will bring a line here and I will write B over here. B. And then I will try to find the child nodes of B. How many child nodes are there for B? 2, right? So I will write 2. Okay. Now you see this. After B, D and E will come. So first one is D. Check if D is having any child node. No. So you represent D here itself. Likewise, E also. Are you understanding? Okay. So this is how it works. Now let us come to C. B part is done. This part is done. Now let's come to C. See here. Is C having the child node? Is C having the child node? Yes. So you shouldn't write C here. Instead, you should have next level like this. So C will come here. How many child nodes are there for C? Just one. So I will write one node. So the value here would be F because F does not have any child nodes. So this is how it is going to look like. And the end nodes that you have to give the value 0. Are you getting? Let me do one more. I think in the example also we have, right? So for this one, let me do. Okay. So list representation for this one. So first is A. Then I will write its child B. Okay. Check if B is having the child nodes. Yes, B is having the child nodes. So write a bracket. Write its left child first, E. Then check if E is having any child nodes. E is having the child nodes. So open the bracket. Then write its left child. And since the left child does not have any other childs, so you come to the right side and you finish it off. So A, B, E, K, L is done. Now you will go back. That is, you'll go back to F and close off that. That level is also done. Now we will come to this part. So, comma. It's B's child, right? B is the sibling, right? So, C. C is having child node, so G. It's only child, so like this, comma. D. Its child node is H. And H is again having a child, so M, comma, I, comma, J. Now balance out the brackets. So 1, 2, 3, 4, 5, 6. Okay, 6 open brackets are there. Closing brackets are 1, 2, 3, 4, 5, and 6. And everything has to be closed off like this. Okay. Sorry. This is how it works. Once you have written the uh, list, now we will actually represent using a list formation. Okay. Let us take this tree first and then we'll try to do the representation. Okay. So let me first copy this. It over here. Now we will try to do the list for this. you might have to leave sufficient space for this because many nodes will be there. So first node is A. How many child nodes does it have? A has three child nodes. So you have to write three nodes like this. One for B, one for C, and the other one is for D. Okay. Now, this is for B. Remember, this is for C. Remember, and this is for D. Now, check if B is having, see, before this, you have to first check if B is having any child node. B is having a child node, right? So you shouldn't write B over here. This is not allowed. So we'll cancel it off. We'll try to bring a node over here. So B will come here. B will come here. B has two child nodes. So I'll write like this. Okay. Now B is left child is E. Correct? Is he having child nodes? Yes. So you shouldn't write it in the same line. It should come to the next line. Okay. So E will come here. And E is having two child nodes. One is K and the other one is L. Now see if K is having child nodes. No, K is not having any child nodes. So write K here itself and L also here itself. This is how it is done. Next, come to this part. Is C having child nodes? Yes. So C will be written like this, followed by its child. That is your gene. Okay. Now come to the D part. So D node, it has three child nodes. One is H, the other one is I, and the other one is J. Okay. So is H having the child node? Yes. So H shouldn't be represented there itself. You have to bring it to the next line. H and M. And here it would be I and here it would be J. And all the end nodes should have 0. This is how you do the list representation. Okay, I'll give you one example tree. You do the list representation for it. Okay. If you can do for this correctly, then I will assume that you have understood the topic. Okay, so that is the first representation. That is your list representation. Then it is left child, right sibling, that representation. Left child, right sibling. So we will do it for this one itself. Okay, second representation is left child, right sibling representation. Left child, right sibling representation. So what you have to do is you have to take the root node first. You have to take the root node. So I will write root node as A. Correct? Root node is A. Then write the left child like this. Left child like this. And all its siblings in the same line. C and D. Like this. Okay. Are you understanding? You write the left child and all its siblings in the same line. Likewise, let us go for the next line. So here. So E will come here and its sibling F will come in the same line. Like this. Likewise, E's left child is K's sibling is L. Like this. Okay, now we'll go to this part. C. C's left child is G, sorry, so I'll write G like this. It should have been a left child, but I don't have space. So that is why I'm writing like that. Then D's left child is H. Then you have its sibling I and then J. Then H's left child is M. This is how you do the left child right sibling representation. Let us do for the first example that we saw. This was the example 1. So I'll take A. Then I'll write its left child. Its left child is B. Then its sibling would come here, C. Okay. Then its left child is D. Then its sibling E. Then F. X. Okay. So this is how it is done. So for the same example that I had given you to solve, for this particular tree, do the left child, right sibling representation. The idea is take the root node first and its left child you write down to the left itself. And then its siblings, you put it on the same level as the, your left child. Like this you have to do. The next one is degree 2 representation. Degree 2 representation. So here it is. Representation as a degree of a representation as a degree 2 tree. So we'll do the degree 2 tree representation. Degree 2 tree representation. So I'll take the same tree, that is this one, and I'll try to do the degree 2. See, the idea is what you do is, okay, take the root, okay, then take its left child, okay, then see, for in order to do that, what is that degree 2 representation, you should clearly know this one. Okay, I always suggest when you do this is, before you do the degree 2, first to do the left child right sibling. Okay, then it is easier to do it. See, I'll tell you why. See, in case of degree 2 representation, first child will remain to the left itself. See here, A will be there. Its child will remain as it is to the left. Then whatever its sibling is there, right? The next sibling, okay, this next sibling was this, like this it is there, right? See, now what you have to do is you have to tilt that one, okay, 45-degree towards the right. So this is how it is going to look like. Are you getting? Okay, and then its child, because it is only one, it will remain as it is. Okay, let me show you for this E one. Okay, so E will be here. Its left, its sibling E will be tilted like this. F. Okay, likewise, K will be here. Its left child will tilt. Okay, are you understanding? Next comes, so D. So D's left child is H. Okay. Now what you do is I you tilt. Sorry, what is it? I you tilt. So it will come here. Okay. Now, what do you do for the J one? See here. 1 minute. So again, this also will be tilted like this. And M will come here. Are you understanding? Let me do one. Okay. So A, B, C, D, E, F. Then I'll do G, H, and I. So first I'll do the left child, right sibling. Okay. So I'll take A. Its left child is B. Its sibling, I'll write it in the same line, C. Okay. Then B's child is D. D does not have any siblings, so leave it. After D, you have E. Sorry, G, like this. But when it comes to the left part, right part, sorry, C's left child is E. E does have a sibling, so this becomes F. Then E's left child is H. Its child, it's a sibling, so I. Now, how do I do the degree 2 representations? I'll take A, then I'll do B. Okay. Then, sorry about the health. Okay. Next, what you do is, so A is done, B is done. Now, C is in the same line, so tilt it. So it will come here like this. And left side, everything is one node itself. So no change, remains as it is. Now, when it comes to C, its left child, you write it as it is. And E sibling, you tilt. So it will come like this. Likewise, draw H node and its sibling, you tilt. Okay. This is how you do the three representations. So, three representations. So, you can take a screenshot of this and then take your own example and then try to do all the three representations for the given tree. Okay. And under this, we have one more topic that I would like to cover. So, that is about the binary tree. I think I should be able to finish it. Yeah. So, what is a binary tree? Binary means what? Binary means basically two. So, one thing is a given tree can be empty. So, if there is no node at all, then there is no tree altogether. But then, if you have a tree, then, okay, for a given tree, the maximum number of child nodes can be two. Okay, there is a root and there can be up to two child nodes. That is your binary tree. See, for example, this one. See, B can be considered as a root. Okay, and it's two child nodes. So it has two child nodes. So see D and E. So I can be considered as a root. It does not have any child nodes. So 0. So the number of child nodes can be 0, 1, or 2. So that can be considered as a binary tree. Binary tree. So look at the definition. A binary tree T is defined as a finite set of nodes such that T is empty or T consists of a root and two disjoint binary trees called the left subtree and the right subtree. So what does this mean? See here. So if I consider this entire thing would be its left part and this would be its right part, right? So this is your left subtree and this is your right subtree. Okay, a binary tree means it should have at least if it can have at the most two child nodes. So it can have no child nodes, it can have one child node, or it can have two child. If it is three, then it is not a binary tree. Okay. So a root and its child. Maximum number of child nodes possible is 2 and minimum possible is 0. That is what a binary tree is. And skewed binary tree. This is also very important. Skewed binary tree. So what happens is, if there is a tree like this, if there is a root like this, if all the nodes are towards its left, any one side like this, like this. So this can be considered as a skewed tree. So if all the nodes are towards its left, there is only left subtrees present, then it is called as left skewed tree. And if the given node has all the nodes towards its right, so there are only right subtrees present, then it is called as a right skewed binary tree. Complete binary tree. This is also very important. Complete binary tree means complete binary tree means when you have a node, okay, except the child node, all the other nodes should have, okay. So here what happens is every node, okay, will have two child nodes. See, complete binary tree. See, for example, here A has two child nodes, okay. C is having two child nodes, okay. B is having two child nodes, okay. And D is having two child nodes. These are called as complete binary tree. Okay. Likewise, full binary tree. Every node should have exactly two child nodes. See here, every node is having exactly two child nodes, except the leaf node, of course. So 6 is having two child nodes, 12 and 13. Okay. So here, this is how it is going to look like. Okay. So you can look at the definition, you can read the definition. And an extended binary tree. See, this is my binary tree. Okay. Now, if you see extended binary tree means you have a binary tree, you have to make it as a full binary tree. Now, what happens is if you look at this particular node, it has only right child, right? So you have to draw the left child. But because it is not a part of the original tree, so that node that you draw has to be shown in squares. So, for example, this node, see, it is having its left child, but right child is not present. So, like this. You have this one, it's left one. So, like this. You have a node here, so it's childs. Like this. So, the existing ones are called as internal nodes. And the nodes that you have just added, these becomes the external nodes. Okay. So, this is how it works. This is your extended binary tree where the existing nodes are already present and you add new nodes so that every node is having two child nodes. Okay. I think so. Here, every internal node is the extended binary tree. It has exactly two children, and every external node is a leaf. The result is a complete binary tree. This property is also this. I think you can study it on your own. There are two properties. Yeah. Okay. So this is all about the first part of your trees. You have seen the definition of the tree, the different terminologies associated with tree, the different representations of the tree, and the different types of trees. Okay. I'll continue the session in the next video. Thank you so much.